Think about this paradox for a second. When you look at human newborns, especially compared to other mammals, they seem incredibly helpless. I mean, they have these huge, heavy heads that make up roughly 25% of their total body size, and they barely have any control over their neck muscles. They just appear totally clumsy and dependent. But here's the crazy part. While they seem completely uncoordinated on the outside, in reality, they've been busy practicing complex, highly organized movements in the dark for months before they ever take that first breath.
Section 1. The 8-week motor milestone.
To really wrap our heads around how this foundation works, just consider the number 3. At just 8 weeks after fertilization, the embryo is only about 3 centimeters long and weighs a mere 3 grams. It is literally incredibly tiny. Yet the structural precursors are already forming at a blistering pace. Even though there are no solid bones yet, cartilage is being laid down. Fingers and toes are forming. The nail beds and hair follicles are beginning to develop. It is just absolutely incredible how quickly this miniature human blueprint comes together.
Section 2. A symphony of fetal movements.
So moving from physical structures to actual behaviors, we can really see what I mean when I say the womb is a training camp. Between just 8 and 12 weeks of gestation, a fetus starts exhibiting what scientists call organized embryonic behaviors. This is not just random, aimless floating around. Fetuses are actively expanding and contracting their lungs, kicking their feet, bending their arms, forming little fists, and curling their toes. They're opening their mouths and even sucking their thumbs. They're actively rehearsing the exact physical motions they're going to need for survival outside. And honestly, seeing a fetus sucking its thumb perfectly captures that early organized behavior we just talked about. Think about it. It takes significant coordination to bend the arm, successfully locate the mouth in the dark, and then execute that sucking motion. It's a huge early milestone of physical development.
And, this isn't just an occasional, accidental bump in the dark, either. Ultrasounds reveal that fetuses actively bring their hands to their faces all the time. In fact, studies observing fetuses between 5 to 9 months of gestation found something staggering. More than half of all the arm movements they observed resulted in the hand actually touching the mouth, either directly or indirectly. The fetus is incredibly active, just constantly exploring its own face and body.
Section 3. Brain and body connection.
Why are they doing this? What's the real purpose behind all this constant motion? Well, the answer lies in this complex academic term, inner sensorimotor action anticipation. Let's break that down into plain English, because the concept is pretty mind-blowing. It basically means the movements we've been talking about aren't just random twitches, they are anticipatory. Researchers noticed that fetuses were actually opening their mouths before their hands came into contact with them. That is a total game changer. It shows true intent. The developing brain is actually sending a signal to the body to prepare for an action before the physical contact even happens. The brain and body are already working perfectly in sync.
Building on that incredible coordination, by the time a fetus reaches 7 months of gestation, all of its core physical characteristics, the hands, the feet, the fingers, they're fully in place. The biological hardware is remarkably set. So what happens in those final months? Well, the remaining time is primarily dedicated to increasing muscle size to power those movements and packing on fat tissue. And crucially, that fat tissue includes white matter, which is absolutely vital for conducting fast, efficient neuronal impulses between that developing brain and the muscles.
Section 4. Practice for the outside.
So how do all of these movements inside the womb actually translate to the real world once the baby is born? Well, neonates come equipped with a series of vital reflexes right out of the gate. Grasping, stepping, and sucking. That newborn rooting around and successfully sucking for a meal didn't just magically learn how to do it upon taking a breath. They literally spent half a year meticulously rehearsing it in the womb.
And perhaps the most critical rehearsal of all is respiratory. Remember earlier when we mentioned the fetus expanding and contracting its lungs? This is vital. In the womb, they aren't breathing air, obviously, but those piston-like movements are actively strengthening the respiratory muscles. Furthermore, late in the second trimester, the lungs begin producing this detergent-like substance called surfactant. This prevents the tiny air sacs from sticking together. So when the baby is finally born and the umbilical cord is cut, those practice expansions and all that biological prep work completely pave the way for the lungs to independently inflate and take that massive, vital first breath.
Section 5. Summary.
Okay, we've covered a tremendous amount of ground today in this explainer, tracing the biological journey from a 3-gram embryo to a complex, moving infant. Let's quickly recap our main takeaways. First, the structural foundation for movement is laid incredibly early, between 8 and 12 weeks. Second, the fetal development period is basically a highly active training ground where random twitches evolve into deliberate, anticipatory movements,
like expanding those lungs, bending arms, and sucking thumbs. And third, all this internal practice guarantees that crucial postnatal survival reflexes are primed and totally ready for birth.
Before we wrap up, I want to leave you with a final thought to ponder. If our most fundamental, life-sustaining movements, how to grasp, how to swallow, how to prepare for a breath, are mastered in the total dark before we are even born, what other incredible capabilities, cognitive or social, might we already possess the very moment we arrive? It truly makes you marvel at the mystery and efficiency of human biology. Thank you so much for joining me for this explainer, and keep exploring.